All right, so this was a worksheet slash lab kind of thing, some extra practice that we were going to do in class before class was canceled. And instead, I posted the original problem plus the solutions on Moodle. If you haven't done them, go ahead and stop the video and um, go ahead and solve the problems and then come back and check them. All right, so one of the nice things about exponentials and logarithms is there are lots of examples that we can do from the real world. We finally got to the good stuff and they cancel class. I guess that's just kind of the way it happens. All right, so carbon-14 has a half-life of 5,730 years. For those of you that didn't know, my undergrad was actually in archaeology and anthropology. I did bones and artifacts. And one of the sites that I was working on we found some artifacts, we sent them in, found a piece of bone, and it came back with 91.1% of the carbon-14 left. And the question then followed up with was, how old is the site? So we're going to use our half-life formula. So the ending amount equals the starting amount times 1/2 raised to the time divided by the length of the half-life. So anytime we're dealing with percents, our starting amount is 100% or 1. Our ending amount is 0.911. Half-life is 5,730, and we are looking for time. So in this case, we have an exponential. We can't solve it. And anytime you have an exponential that you can't solve, you make it a log. So the log of 0.5 of 0.911 equals t divided by 5,730. We're going to take the log of 0.911 divided by the log of 0.5. Make sure you close parentheses after the 0.911. And we get 0.134 equals t divided by 5,730. Cross multiply. And the archaeology site is about 770 years old, which was about what we thought just by what we'd found on that case. All right, number 2. Got a new product, we heavily advertise, then we're going to reduce it. So peak sales is 30,000, and we're given a model. T is time in months. How many sales will there be after 6 months? Now, when you're doing these, once you have the formula, you really can just ignore the rest of the problem. All that's doing is giving you context. So we know what time is. T is 6. Everything else we can just plug in the calculator. Do not forget to put parentheses around the denominator. So parentheses before the 1 and then after the 6. And after 6 months, there's going to be 187,663 sales. Just a straightforward plug it in and done. All right. Number 3. We have bison. Number of bison in the per acre range in the wild is given. If there are 5 animals per acre, what is the average weight of the bison? So this is one of those cases where when I was teaching high school, I had the 10 commandments of math. And one of the commandments is make sure that the answer makes sense. Okay, so if you're dealing with this and you find out that the bison, if your answer is 47 or something like that, bison don't weigh 47 pounds. They are massive animals. The answer doesn't make sense. Obviously, it's got to be a wrong answer. Okay, for all of these, anytime I give you something like this, it's going to be something that actually makes sense. It's going to be something that's applicable to the real world. Okay, same thing if you get 2 million. Okay, bison are big. They're not 2 million pounds. Okay, so make sure that your answer has to make sense. All right, so plugging 5 in for n, we end up with 5 equals 2.5 times 10 raised to the 5 minus 0.003w. All right, you cannot take 2.5 and times it by 10. If you remember your order of operations, you do exponents first and then multiply. Well, since you can't do the exponent, then you can't multiply. Okay, so we're going to have to divide the 2.5. So 5 divided by 2.5 equals 2. So 2 equals 10 raised to the power. It's an exponential. We can't solve it. We're going to make it a log. So log base 10 of 2 equals 5 minus 0.003w. Your calculator is already programmed to log base 10, so we can just plug that in. Log base 10 of 2 is 0.301. Subtract 5, we get negative 4.699. And if we divide that by negative 0.003, we're going to get an average weight of 1,566.323 pounds. So if there's 5 bison per acre in the wild, they're going to average a weight of about 1,566 pounds. All right, number 4. We have a rumor being started on a high school. The school is a half day. There are 2,600 students, and the spread of the rumor is modeled by that. I want to know how long before 2,000 students have heard the rumor. So we're going to plug 2,000 in for y. We're going to cross multiply. So 2,000 times 1 plus 2599 times e to the negative 0.6 times t. You could distribute that 2,000 all the way through, and it would work perfectly. You would just end up with big numbers. So instead, I'm going to divide. So 2,600 divided by 2,000 is 1.3. Subtract the 1, we get 2,599 e to the negative 0.6 t equals 0.3. We're going to divide that by 2,599, and that's going to give us 0.0001 equals e to the negative 0.6 times t. All right, so we need to get rid of an e. Well, the inverse of e is the ln, so if I take an ln to both sides, the natural log, the ln of 0.0001 is negative 9.067. On the right side, e's and ln's cancel, and I'm left with a negative 0.6t. Divided, and we're going to end up with 15.111 minutes. So just after 15 minutes, the rumor is spread, and 2,000 out of the 2,600 kids have already heard it. All right. So some of you may remember the earthquake and tsunami that hit Japan. There was some nuclear material that leaked out. It was cesium-137. Has a half-life of 30 days. And according to reports, 3,980 grams were released. So it's 3.9, almost 4 kilograms. It's about 8.5 pounds of material. So how long until 100 grams remain? So we're going to go back to our half-life formula. 100 is our ending amount. 3,980 is our starting amount. 1/2, and then we're going to raise the t divided by 30. So we get 0.025 equals 1/2 raised to the 1t divided by 30. It's an exponential formula. We can't solve it. We're going to make it a log. So log of 0.5, log base 0.5 of 0.025 equals t divided by 30. Take the log of 0.025 divided by the log of 0.5, and we get 5.315 equals t divided by 30. Cross multiply, and in 159.44 days, our 3,980 grams is decreased to 100 grams. All right, number 6. After 300 million years, I have 70% left of a radioactive material. What's the half-life? So dealing with percents, starting amount's always 1. So 0.7 equals 1 times 1/2 to the 300 divided by L. In this case, 300 is time. We are looking for half-life in this case. Exponential form, can't solve it. We're going to make it a log. So log 0.5 of 0.7 equals 300 divided by L. To solve the left side, it's the log of 0.7 divided by the log of 0.5, which is 0.515 equals 300 over L. And cross multiply and divide, you get L equals 300 divided by 0.515, which means the half-life is approximately 583 million years. All right. If I have $6,000 in credit card debt and interest rate's 2.4, how many monthly payments does it take of $200 to pay it off? So this is our present value formula. So 6,000 equals 200 times 1 minus 1.025 raised to the negative 12 times t over that should be 0.24 divided by 12. So once again, I cannot distribute the 200 all the way through because I have not dealt with the exponent yet. So we're going to divide. 6,000 divided by 200 is 30. We're going to times that by 0.02, so I get 0.6 equals 1 minus 1.02 raised to the negative 12. Subtract 1, I get negative 0.4 equals negative 1.02. Well, two negatives make a positive. It is in exponential form. I can't solve it, so we're going to make it a log. So the log base 1.02 of 0.4 equals negative 12t. And log of 0.4 divided by the log of 1.02 is negative 46.211 equals negative 12t. Divide by negative 12, and it's going to take you 3.856 years to pay off your loan. All right. We have a nurse. The half-life of a drug is 5 hours, and the patient is told to take the drug every 8 hours. How much drug is left when the next dosage is taken? So, starting amount's 100%. 1/2 raised to the 8 is the time. 5 is the half-life. If you're going to plug that all in the calculator, I would put parentheses around the 8 divided by 5. Plug it all in and you get 0.33. Alright, so Josh is buying a car for $21,060. 3 years later, it's worth $12,004. What is the annual rate of depreciation? So the amount, ending amount equals starting amount, parentheses 1 plus the rate raised to the t. So 12,004 equals 21,060. 1 plus r cubed. We're going to divide, and we get 0.570. And then to get rid of the third power, I'm going to take a third root. The cube root of 0.57 is 0.829. If I subtract the 1, it's a negative 17.1%. In other words, the car is going to lose 17.1% of its value every single year. All right, and the last one. This would be Newton's law of cooling. So we got a roast. Starts at 35 degrees. We're going to put it in the oven at 325. 4 hours later, it's at 139 degrees. How long is it going to take to hit 175 degrees? So the difference at time t equals the initial difference times e raised to the k times t. K is a constant. Okay, so this is Newton's law of cooling. So the initial difference would be 35 minus the 325. So that's a difference of negative 290 degrees. T is 4, so we're going to put a 4 in. And at 4 hours, if we take 139 minus the 325, we're going to get negative 186. So the first thing we need to do is solve for k. So we're going to divide and get 0.641. Take an ln to get rid of the e. The ln of 0.641 equals negative 0.444. E's and ln's cancel. I'm just left with a 4k, and k equals negative 0.111. All right, so plugging everything back in, now we got to solve for t. So we want to know how long is it going to take to hit 175 degrees. So 175 minus 325 is negative 150 equals our negative 290 e to the negative 0.111t. That was the k that we just found. And now I'm really just going to repeat the process. So we're going to divide. Negative 150 divided by negative 290 equals 0.517. ln to get rid of the e, we get negative 0.659 equals negative 0.111t. Dividing by negative 111, we get 5.959 hours. So that's how long it's going to be in there total. It's already been in there 4 hours, so 1.959 hours is what is left.